Now we'd like to take a look at the third type of chemical reaction. It's called single replacement. Well, let's just go through all five. We have synthesis, decomposition. They're basically reverse reactions. Single replacement, double displacement, combustion. So we're on single replacement. Single replacement means exactly what it says. One element is going to replace another one. It could be a metal replacing a metal, or a non-metal replacing a non-metal. And the easiest way to do this is just to do some examples. So let's take potassium, and we'll let that be one of our elements. And we're going to bring that next to an ionic compound called zinc chloride. So if I have zinc chloride, and I write the oxidation number, zinc is +2, chlorine is -1. Remember, you look these up on the periodic table. I use the crisscross method. Here's my formula. Zinc, Cl2. So zinc chloride looks like this. Potassium, because it hasn't bonded yet, has no oxidation number. It's a 0 because it hasn't bonded. Now, the question is, what's going to happen here? Potassium's a metal. So if it's going to replace anything, it will have to replace a metal, which would be zinc in this case. Why would potassium replace zinc? The answer is you need to have a more active metal. Is potassium more active than zinc? If it is, it will replace it. So how do we know? Right on the left here is a chart of standard reduction potentials. And basically what it shows you, if I can zoom in a little bit here, shows you the activity of nonmetals and metals. If you notice at the top, fluorine is actually the top one. If we go down to the bottom, we have lithium down there. Okay? And I'm going to leave it down here because we're dealing with metals right now. The most active metals are at the bottom. Lithium here is the most active metal. You can also see potassium's right there. Okay? And zinc is quite a ways up. Zinc is up here. So by this chart, the metals are more active the farther down you go. The nonmetals are more active the farther up you go. But we're dealing with metals. So we look here. Lithium's the most active. Potassium's the third most active. Zinc's up here. So potassium is in fact more active than zinc. We know that this reaction will take place. So potassium goes with chlorine, and zinc is replaced. We do our oxidation numbers. Potassium is +1, chlorine is -1, zinc is 0 there. So our formula for potassium chloride is correct. Again, don't be fooled by that subscript. That is for this formula. This is a completely different compound. By inspection, we look to balance the equation. With 1 potassium, 1. That's not a problem. 1 chlorine, but 2. So we're going to need to put a coefficient here, which will change the potassium. Zinc, there's 1 of each, so now we're good. Again, if we want to deal with exo and endothermic, you can see this is already more active, so you wouldn't need to add energy to get it to work. It'll work by itself. So we would add energy on this side. This would be +E. Let's try another one. What if we wanted to do potassium and lithium chloride? Now, I don't want to go back to the chart because I already showed it to you. We said that lithium is the most active metal. Although potassium is pretty active, it's not as active as lithium. So in this case, nothing's going to happen. There will be no reaction. So we would just write it, no reaction. Now let's switch gears and go to the nonmetals. Let's say that we have sodium bromide, and we're going to bring chlorine to it. Now chlorine is a Hofbrinkel element, so it doesn't exist by itself. So we need a 2 there. Let's do our oxidations, +1, -1, so that formula is okay. Now, will this reaction take place? We need to look at our chart again. We're focusing on the nonmetals. Fluorine is the most active nonmetal. So fluorine can replace any other nonmetal, but no other nonmetal can replace it. But we're not looking for fluorine right now. We're looking for chlorine right here. And we're also looking for bromine right here. You can notice that as you go up the chart, the nonmetal activity increases. So bromine is below chlorine, which means bromine is less active than chlorine. Chlorine is more active than bromine. Based on what we just said, chlorine will in fact replace bromine. So we'll have NaCl plus bromine. And bromine is a diatomic molecule, so it needs a 2 there. If we put in the oxidations, we have +1, -1, and 0, because it doesn't bond anymore. We look for balancing. We see 2 chlorines here, only 1 there, so we're going to need to put a coefficient. 2 sodiums, so we're going to need 2 here. 2 bromines produces 2 bromines. So that works. Again, energetically, this is exothermic because chlorine is more active. It's going to happen spontaneously. We can put the energy as a product over here. What if we wanted to try this? Sodium fluoride plus chlorine. And I picked that one on purpose because it should be obvious. The formula here is correct. Now, based on the chart, and we looked at the chart, fluorine is the most active nonmetal. It is more active than chlorine. So there's not going to be any replacement here. No reaction. So you'd simply write no reaction.